gas training, how to take out a Hydroblock on a Worcester Bosch Combi boiler. My name's Alan Hart, and in today's video I'm at Viva Training Academy, and we've got Roy with us today, who is the trainer at Viva Training Academy, and Roy has got a lot of experience on boiler repairs, etc. And Roy's going to go through taking out the Hydroblock on a Worcester Bosch boiler, but it's also going to go through what the different components do and mean, so that if you are coming to a Worcester Bosch boiler and you're going to strip it down, then hopefully you will understand better what you're doing and what each component is and what it does. So yeah, without further ado, let's go over to Roy. This video is for gas safe, registered and trainee gas engineers under supervision. Please comply with the current regulations at the time.
Hi guys, it's Roy Fugler here again at the Viva Training Academy over in Halifax, and today we're going to have a look at the Worcester Green Star 25i. Before we started, I've isolated the electricity in accordance with TB118, which is a gas safe technical bulletin. We have done a previous video on that, so I didn't want to bore you with going through that again, but it is important to make sure that you isolate the electric properly. I've also turned off the water to the boiler and drained the boiler down, so it's ready for us, so we're not showing you things that take up time. Before I start, I've got my gloves on to protect my hands. I've got my glasses there for when I need them, and I'll put them on. I've also got a set of instructions. It's most important when you're not familiar with the boiler, and for those people that know me, the last 20 years I've spent working for Baxi, so I'm not overly familiar with Worcester, so I will be referring to these as we go through to make sure I don't take things out I shouldn't do. So without further ado, let's get the front off. So there's just two screws underneath, one at either side, just little self-tapping screws. They pop out. So ease the front forward, remove it, and then we'll tap it to one side. So the first thing we're going to do is drop the front down so we can get access to the hydraulics, because the first thing I'd like to do is remove the Hydroblock. In a previous video you saw me remove the Hydroblock and all the parts out of the Baxi, so I'm going to do it on this one. So I'm going to take the Hydroblock out. So at the next stage I'm going to have a quick look in the instructions to find out how I do that, and I've already preempted it. It's basically on page 61, and it's removal of Hydroblock. So that's what I'm going to be doing next. So the first thing in the instructions it refers to is removing the siphon. So that's the siphon, and it's a simple matter of a self-tapping screw. So we'll pop that screw out. And then we've removed the pipe off the back of the siphon. It's just a little push fit fitting. We then rotate it to the right hand side, ease it down, and then we can remove the siphon out of the boiler. The next thing that it talks about is disconnecting the temperature sensor, the NTC sensor. That's just a simple matter of lifting a little clip up. Obviously we drain the boiler down, and then we just pull that forward, so we've totally removed that, and then we can unclip it if we need to, and we've got the sensor there. So referring back to the instructions, it talks about undoing the copper pipe nuts, the nuts onto the connections. We don't need to remove the gas valve, so we're just going to do the flow return hot and cold. So that's my next port of call. So I'm just undoing these so that they're finger tight. Obviously we've got the boiler drain, so there's no water coming out. Make sure we get the right size. So we've now got those out. So I need to refer back to the instructions to check what I need to do next. So for those of you with a keen eye and have got a set of these instructions, you may have noticed I've slightly missed a little bit. I've jumped ahead because it says disconnect the electrical connection of the NTC sensor, turbine and pump. I didn't do the turbine and pump, so I'm going to do that now. I'll also do the one on the diverter valve because that'll need to be undone. So the one for the turbine is a little intermediate plug just up at the top, so I've just undone that. The plug, there's one on the front of the plug which comes out, that's the mains cable. And this being an ERP boiler, energy related product boiler, there is a second plug just at the back. The diverter plug is just underneath, so I'm just going to unclip that one. So now all the electrical connections to the Hydroblock have been removed. The next stage, according to the instructions, is to remove the clip or loosen the clip on the expansion vessel connection. And having spoke to Alan, who's took a few of these in bits in the past, he recommends that I also undo the nut up on the expansion vessel itself, which will allow the pipe to become free floating, so it's not as tight when I need to remove it. So I'm just going to pop that pipe up so it pops up out the Hydroblock, so when I need to remove the Hydroblock it's free. The next thing is the pressure gauge. Now on this boiler, which has been in the training centre for a while, there's no clip on there. I'll show you when we get into the into having a real good look at the Hydroblock on the desk. So this one is just a matter of unplugging it. Normally you would pull a clip out. We'll have a look at that a little bit later on. So the next stage, I'm going to have a look at the instructions again just to make sure I'm doing it in the right order. So the next stage is to release the locking devices that secure the two copper water pipes leading to the combustion chamber. So what it's asking me to do, there are two locking nuts which I need to grip the tabs and close them together, and then that will release those two pipes. Now I've spoken to Alan, and Alan's suggestion is using a pair of grips to grab them because sometimes they're a bit too tight to use your fingers. So the one up on the left hand side, I've had a little go with this. I can get my hand in there and I can move that round and slacken that off. The one on the right hand side, obviously it's above the pump, it's a little bit more awkward to get your hands in, so that's where the grips come in. So I'll bow to Alan's superior knowledge on this boiler. So I'm just going to nip that in. It just starts to move it, so you're not damaging it. Yep, and that's freed off. So the next stage, it talks about dropping the connection for the PRV. So underneath on the right hand side, there's a little tag, and it's a little plastic tag, and we just pull that down and that just frees the PRV connection underneath. So the last part of removing it, there are two screws, one on the right and one on the left of the Hydroblock. So we slacken one on the right hand side and one on the left hand side. Once these two screws are out, it should be just a case of lifting the Hydroblock and easing it out. So that's one screw. The other screw's captive, so it's still in there. So according to the instructions, we lift it on the left hand side and then it should free off. Hopefully we've got all the nuts out, all the pipes off, and we should then be able to remove it. Right, so we just lift it up on the left hand side, bit of a jiggle about, and then we've got the whole Hydroblock out. So the next thing, we're going to pop it on a desk and we'll go through talking about all the different components and how the Hydroblock functions. So we've got the Hydroblock out on the desk, so we're now going to take some parts out. I've already earlier on removed the hot water thermistor. It's what's called an NTC sensor, negative temperature coefficient. So basically this is what tells the circuit board how warm the water is. It does it by a resistance reading. Now to test these, it's quite simple. You can use a multimeter across the two connections, it will give a resistance reading. And in the instructions, there is a chart there which will give you the resistance reading at various temperatures, so you can check that. So we've already removed that. So the next thing I'm going to remove is the pump head. So it's a 4mm Allen key, So I'm just going to undo the connections on here. They are pretty tight. So remove the 4 screws out the pump, and it's just a case of lifting the pump head out. So that's the pump, that's the impeller which pushes water around. When I explain things, I try to explain them in simple terms. So to me, a pump is very much like my heart in my body. My heart's pumping blood around me for circulation. That's what the pump's doing in this boiler. It's pumping water round the boiler, round the radiators, or through the plate heat exchanger, which we're going to go on to shortly. This is an ERP pump, energy related product. That came in a few years ago to make sure everything's energy rated. That's why you've got 2 connections. You've got the mains connection in there and a low voltage connection. That communicates back to the circuit board, and it decides at what speed the pump needs to run dependent on the load of that system. So that's the pump. So we're just going to pop that back down to one side. So on the back of the pump housing, so that's your pump housing, the pump body, there's an auto air vent. The purpose of that is any air that's in the system, any air that when you're filling a system up gets trapped in there, when it gets to the pump, it's vented, it gets rid of it. That's a replaceable part as well. It's simply a matter of using an adjustable spanner adjusted to the right size, which I've done with this one, and then we just pop it on there, and it's literally a 1/4 turn. So we just turn it 1/4 of a turn. Once we've got that there, we can pop that out, and as you can see, that comes out. It works very similar to a toilet cistern, the ball float in that. You have a little float that when water is there, it's happy, and any air, it allows that float to drop. So the water level rises, closes off the air vent. It's important when you install a boiler or do any maintenance that you make sure that that cap is just cracked open. That's a dust cap. If that's left shut, you're going to trap the air, which is going to get pushed around the system. So that's an auto air vent. The next thing that we're going to look at is the water turbine. The water turbine in effect is the hot water flow switch. So it's behind this pipe. So I'm just going to remove this clip. Once this clip's out, just pop the clip out, I can remove the pipe out the way. So we can take the pipe out. All these components can actually be changed in situ when the boilers, the hydroblocks on the boiler in the wall. I've just done it in here just to make it a little bit easier to see what we're doing. So the turbine, that slips out, and that's a sealed unit. There's a little arrow there to say that the water's flowing the right way through, because if we don't get the water flowing the right way through, it won't detect the water flow. Not only does it detect the water flow, it also detects the speed of that water. And again, that communicates with the main circuit board on that boiler to determine at what rate that boiler needs to fire, its modulation rate for hot water. So that's the water turbine. Now inside there, there's also a filter and a flow restrictor. So you need a little pair of pliers to pull that out. So once we get in there, that pops out. Now, there's a little tip with these. Obviously, me not knowing too much about them, Alan's given me another good tip. So this part inside, which is the flow restrictor and filter, it's just a simple matter of unscrewing it. So this little white part here comes out. It completely comes out. So we've got the filter and we've got the flow restrictor. Now with these, occasionally when people put them back together, because that's a separate component to this piece. So if you bought a new one of these, if you needed a replacement, that one you would take out the old one. So it fits in a specific way. It has the little lip at the top. If you pop it in the wrong way around, when you come to tighten that back up, it doesn't go all the way back to the haunch. So when you pop it in, it stands out further. You put the turbine in and you struggle to get the clip in. So that's just a little tip from Alan. So if you ever take one of these out and strip it down to clean it or to replace the internals, make sure that it goes in that way with the little lip in, and then when that tightens up, there should be no gap at the back of there. So the next thing we're going to look at is the diverter valve. So there's a little rubber boot which covers over the top of it, so that just easily pulls off, and then we've got 2 screws. So if we remove the 2 screws from there, again, because these are in water sections, they're all pretty tight. So get those 2 out. So 1 and then that should just free out. So this is the diverter valve. Now it's actually in two parts. There's the motor and there's the paddle section, and that just splits in two. So that's the little motor that activates it, and this is the little paddle that either moves it up or down dependent on whether you're wanting heating or hot water. On a combi boiler, if you're not familiar with combi boilers, they can't do both heating and hot water together. They haven't got the capacity, so it's either in heating mode or hot water mode. So one of the problems that you can get, obviously this one's been in a boiler, there's a little bit of debris or dirt on it that you can see. One of the things that can happen with diverter valves, you can get a little bit of dirt on the seats, so that then the passing water either through onto the heating side when you're asking for hot water. The customer's complaint will be then the hot water isn't warm enough and the radiators are getting warm. Now we're filming this in winter, so I'm not going to be complaining that my radiators are getting warm. I want my radiators warm. What I might be complaining at is my hot water's not warm enough. Now another thing with combis is they only heat water from a cold temperature, generally by 35 degrees. This time of year in winter, the water's coming in a little bit colder, so we won't get as hot as water as we would in summer. So we might misinterpret that complaint from a customer of my water's not warm enough, of well, it's due to weather conditions. So it's always best to check these things out. This can quite easily be removed, cleaned, and made sure that it's actually activating correctly. So that's just the diverter. So that's the actuator part, the little paddle that moves up and down, and then that's the motor section. So the next thing we're going to look at is the plate heat exchanger. So I've got two screws, one on each side of the Hydroblock. So I'm going to undo this side. I've just undone that screw, and the other one over here. And then that should allow me to lift the Hydroblock away from the plate heat exchanger. So I've got the Hydroblock, I'll just pop it to that side, we'll come back to that shortly. So this is the plate heat exchanger. So basically what I've got is cold water coming in, hot water coming out, flow coming down from the main heat exchanger on the boiler going into it, and return water going back to pick up heat from the main heat exchanger. So if I just turn the Hydroblock round, so we can see the cold water is coming in there. So the cold water is actually entering the Hydroblock in that section there. So the cold water is coming in, and the cold water will go up and down through these plates and move across, pick up heat, and then it will come out through the other side. The water coming down off the main heat exchanger is coming in, and it's coming down into this side, and then it's coming out and it's returning back up through the pump. So basically the waters do that. So your cold water comes in and goes across that way, goes out warm, and the flow comes down off the boiler and goes through that way. So the two hottest points are at that side, the two coolest points are at that side. In future videos we're going to look at testing plate heat exchangers, so that's when we're going into the more advanced fault finding side of it. That plate heat exchanger is sealed on the back of the Hydroblock by some O-rings or washers. Those are the large washers that seal that. So the last couple of things we're going to talk about is the PRV. PRV stands for pressure relief valve. The idea behind that, the boiler, when we heat water, it expands. There's an expansion vessel in there, and if that water expands too much because a fault occurs, that PRV is designed to discharge water if it gets up to 3 bar pressure. Now at about 2 1/4 bar it would start to drip, but at 3 bar it would be full bore. Now one of the things that we shouldn't do with PRVs is use them to drain boilers. The downside of doing that is potentially you're going to get some dirt on it. So this PRV, there's a little clip that we can just slide out or slide down, take the PRV out, and then again that's a replaceable part. So we'll pop those two down to one side. So the last thing we're going to talk about, I'm just going to turn the Hydroblock back around. The last thing I'm going to talk about is the bypass. That's this pipe here. The idea of a bypass is if the pump is working hard, the thermostatic radiator valves have started to close down. The system could have been 8 or 9 radiators. The rooms, the areas that the radiators are in start getting up to temperature. those thermostatic valves close down, so that radiator is shut off in effect, so the system becomes smaller. So the idea of the bypass is so the pump isn't straining, it's actually going to carry on pumping water around. So the bypass on this boiler is that pipe, but there's a little bypass valve inside. So if we just remove that clip, or pop that clip out, and we just pull this pipe out. So we've took the pipe out, so inside there we've got the little bypass valve, so we just need a little pair of pliers to remove that. Just inside there, and that pops out. Now that's a little sealed unit. Now inside that there's a little spring and a seat. Now again, one of the things that can happen, this is in the central heating water, or the primary water as we sometimes call it. So as we all know, systems aren't always as clean as we'd like them to be. So one of the things that can happen, we can get some dirt sitting on here, very similar to dirt sitting on the diverter paddle. Now if we get dirt sitting on here, the water that's circulating round, supposedly around our heating circuit, it's not going to go around the heating circuit, it's going to go around the bypass. So the boiler is going to get up to temperature reasonably quickly before the radiators start to get warm, dependent on how much dirt's on that seat. So one of the complaints you could have from the customer is, my heating's coming on but my radiators don't get very warm, my boiler's firing up and shutting down and firing up and shutting down. So it's always worth checking the little bypass valve. It's a simple little thing like that can cause all sorts of problems. So before you go down the lines of changing things like pumps, look at the simplest things. So that's how we'd strip the Hydroblock on this Green Star. I'm going to put it back together. I've been Roy Fugler. Thanks very much for watching. Join us soon at Viva Training Academy.
Thank you very much once again to Roy and to Viva Training Academy. Viva Training Academy are putting a lot of effort in to help you guys. So yeah, thank you so much to them. And if you've got any questions, please ask them in the comments below. Also, if you could, please put a thumbs up, share the video, all that good stuff. Really helps with these videos. And if you've not to say, if you can't think of a comment, just put a comment in, just put Worcester, or just put something that you'd like us to do next. So if you want us to do another video on something to do with boilers or gas or whatever, if you put it in the comments below, and again we'll try and do what we can to help you. I hope this has been of some use, and thank you for watching.